Hi students, today we're going to be looking at trigonometry equations. So we're going to be solving equations using some of the stuff we've learned about trig. First off, we've got to take a look at what we're actually doing here. And we've got this trig equation, which is negative 2 square roots of 2 is equal to negative 4 sine of theta. First thing I've got to do before I even kind of figure out what I'm doing here is to maybe get sine of theta by itself. And then we can talk about what this process is actually doing for us. I'm going to divide both sides by negative 4. And when I do that, I get the square root of 2 over 2 is equal to sine of theta. This means a couple of things for us. First of all, hopefully you recognize that as a nice unit circle value. And the second thing is that this tells us what we're looking for here, which is all angles that have a y value of the square root of 2 over 2, because that's what we're dealing with in terms of sine. In terms of graphically, I could draw a horizontal line at a height of the square root of 2 over 2. And one of the things that I notice is that in my first time around the circle, that seems to happen twice, at pi over 4 and at 3 pi over 4. What that means is that those are our two basic values, so theta equals pi over 4. Theta equals 3 pi over 4. And what we could do with this is go around, I don't know, so that's one extra time around. I could go around any number of extra times. So we often label these as far as like these would be what we call particular solutions. But then we can go around 2 pi n as many times as we want. The same thing for the other one. To prevent this from happening, we often put some limitations on our equation so we don't have to consider that there are an infinite number of solutions, because I could just keep going around and again and again and again and again. But I'm going to try to avoid giving us problems that we have to consider that just because it takes a little bit of extra effort to deal with that. And I really want to make sure that we're okay with the solving portion. This is what I mean by making it a little bit easier for us. I'm going to limit us between 0 and 2 pi, which means one trip around the circle. I don't have to worry about going around multiple times. Let's take a look at our second one. So we've got negative a half is equal to negative 1 plus cosine of theta. First I'm going to get cosine of theta by itself. I'm going to add 1 to both sides. And when I do that, I've got a half is equal to cosine of theta. I know cosine of theta is my x values, so I'm going to look for where x is 1/2. All right, so that's here. I'm just going to draw my vertical line just so I can see this visually. And I can see that I've got two locations between 0 and 2 pi. So theta equals pi over 3. And theta equals 5 pi over 3. For the next one, I've got negative 2 times, or negative 2 of the tangent of theta. So negative 2 times the tangent of theta, whew, took me 3 times to say that, is equal to negative 2. Okay, well, let's divide by negative 2. And we get tangent of theta is equal to 1. What this means is that my y value divided by x value should be positive 1. In other words, they've got to be the same. One of the things that I notice is this happens in the first quadrant. Second quadrant, that would be negative. Third quadrant, they're both negative, so we're okay. And then fourth quadrant, we got 1 of each. So that doesn't really work for us. And again, we're looking just between 0 and 2 pi. My answers to this are going to be theta is equal to pi over 4, and theta is equal to 5 pi over 4. Both of those values work for us. We also have to be able to do a little bit more work in terms of solving these things, and by that, we might see something that involves some factoring or some basic identities. This is an example of one that's going to involve some factoring. I can tell because I've got squareds and not squareds in the same equation. And to start this off, I'm going to get everything onto the same side. So I'm going to minus cosine squared theta to both sides. That gives me 2 cosine squared theta. I'm going to put the minus 1 all the way at the end. And I'm going to minus cosine theta to the other side as well. The other thing that I'm going to do is do something called some u substitution. I'm going to replace cosine of theta with the letter u. I could use an x or a y or whatever. I chose a u because we're not using it for anything else. And what that lets me do is something that's kind of cool, because I can replace cosine squared with u squared. I can replace minus cosine theta with minus u. And then we got minus 1 at the end. This is equal to 0. So this is a nice factorable thing, and I'm going to factor this. So we've got a 2x, or 2u, and a u. And if I want this to be a negative middle number, I'm going to make this a minus 1 here, and a plus 1 here. I can check to make sure this works, but I've got my two pieces here. So we've got 2u plus 1 is equal to 0. That means that u is negative a half. And as we said, cosine was u. Cosine theta is negative a half. For my other part, I've got u equals 1. That means that cosine theta is equal to 1. And that's going to give me another value. So let's get these trig values. For cosine theta equals negative half, I'm looking for x is negative a half. That's going to happen here and here. So at 4 pi over 3 and 2 pi over 3. So I'm going to write maybe under my unit circle just to keep track of these things. So 2 pi over 3, 4 pi over 3. And then for cosine equaling 1, that only happens at one place. And I'm going to be really careful here that I include 0. I do not include 2 pi as my answers. So 0 would be my third angle for this. If we have two different pieces, you might expect we'd have more than two different answers, because we got two answers when we had one part to solve. And that's definitely the case here. Let's look at another one of these involving tangent. Here I've got some squared stuff, some not squared stuff. Let's bring everything over to the same side. I'm going to make my tangent squared part positive and add that to both sides. So we've got tangent squared theta plus 2 tangent of theta, and I'm going to minus 1 to both sides to get plus 1, and that's equal to 0. I'm going to do the same thing I did before and just make u equal to tangent of theta. If you can see the factoring without this, you don't need that, but this is a really helpful strategy. So we got u squared plus 2u plus 1 is equal to 0. That factors into u plus 1 times u plus 1. That gives me u equals negative 1. So you've got tangent of theta is equal to negative 1. Both parentheses in this case are the same. And that's going to happen when we have opposite but equal values. And those are at 3 pi over 4 and at 7 pi over 4. The other thing we may have to deal with is with stuff with some identities. And here our goal is to combine things into as few things as possible. One thing I noticed, I've got both sine and secant here. So it might make sense to try to convert things into sine and cosine and see if I can make some sense of that. So when I do that, we've got negative square root of 3 over cosine theta plus 2 sine theta over cosine theta. And I also notice I've got a plus 2 sine theta on both sides. So if I subtract that, both of those cancel out, and that gives me 0. Okay. So I noticed something kind of interesting here, that if I combine these fractions, we end up with negative square root of 3 plus 2 sine theta over cosine theta is equal to 0. First thing I notice is that anything that would cause cosine to be 0 is going to give us an undefined thing. So I'm just going to write that here. Think back to our rational equations. So theta cannot be pi over 2 or 3 pi over 2. I don't think it's going to be an issue for this problem. But if I multiply both sides by cosine of theta, we end up getting rid of that from the bottom and getting negative root 3 plus 2 sine theta is equal to 0. Getting sine theta by itself, we end up getting the square root of 3 over 2. This happens at two places when y is square root of 3 over 2. That tells us that theta is pi over 3 and 2 pi over 3. Again, I'd like us to notice that these are not the values we got for things that we couldn't use, so we're okay.